Hello, everybody. I hope you're doing great today. Well, today we start this new project that is learning about databases. Yeah. And the main idea for this project is because I was talking with a few companies and they've been complaining that they're not, they've been hard to find people to work with the databases. And I've also been talking to people that want to start working with database, and they've been finding it too quite complicated or expensive to get inside of this area. So we're trying to do it here, and this is the main motivation for this project. Well, I'm dividing this project in modules. So this first one will be an introduction to the database. And we're gonna talk about the basic concepts and data modeling, SQL. So it's really introduction. If you've never worked with database before, this is the module for you. So this is the first one. And here we're gonna have all the base concepts we're gonna introduce that you. The first class today will just be a really short introduction. So I don't want today to extend too much. And then we're gonna evolve for modeling on how to write SQL and how to get the data from the database. So it's technology agnostic, this one. It doesn't matter which database you use. This first one, this introduction, is for you. So we'll give you the basic concepts. The second module, we're going to start with Postgres, more focus on Postgres. And that's going to be focus on database administration. So, yeah. And we're going to see how to install the database, how to go with the configurations, tunnings, and that's how to start the DBA live on the next module. And the third module would be more focused on availability. So we're gonna work with high availability using tools like Patroni, setting up backup solutions using PG Backrest. So let's put on this way, gonna be a bit more advanced phase of the second module. On the second module, you're gonna learn how to install the Postgres, how to build a replication, how to use this APG-based backup with some Postgres tools. And the third one, we're gonna expand this to have high availability, to understand how we can design a high availability environment for Postgres. And the fourth one, we're gonna work on troubleshooting. So we're gonna learn how to troubleshoot slow queries, how to troubleshoot slowness on the database, not related to the database itself. Sometimes we have problems related to the OS or to the virtualization, or even to the network. That's gonna be our last one. And if you follow along, after the fourth module, you gonna have enough knowledge to start your life as a DBA. So, and this is our objective. Those are our goals here. And let's start. So this is the introduction. So today we gonna introduction basic concepts, right? And our agenda, we're gonna have a short introduction for the classes today and for the module that we're starting today. The motivation of this module, why we need to learn about data modeling and all those topics. So we're gonna see this motivation today, and then we are going to understand data and information. Is data and information the same thing? Are they different things? So we're gonna learn a bit more about data and information. we're gonna then understand what is a database management. What is a database and what is a database management system? Are they the same thing? Is there any difference? And we're gonna jump on Postgres as the last one for the agenda today. Okay, as I explained before, this module aims to introduce the basic concepts of databases. So here you're going to learn the difference about data and information. We'll see that we have difference on data and information. They're not the same thing. And how we can extract knowledge, how we can extract, how can we build knowledge based on data and information. So with this basic understanding, we're going to start to build the foundation of the data modeling process. So, and we'll see how important is the data modeling process, why it is important, and what are the benefits. We will then jump into the database. So we see what is a database, what is a database management system, are they the same, are they different, how we can start work with them, what are the database management systems in the market that we have today, the most common ones. So we'll see where Postgres fits into the many database management systems that we have today. And in the end, I'll show you just a really quick overview about Postgres, a bit of its history, not much, because the objective for this first module is not to go deep inside of Postgres. We just use it as a tool because we need to have a database management system to run the queries that we're gonna create here. So, and the one I've chosen is Postgres. I'll show you the client that I have here. I'm gonna show you some commands, and then I'm gonna post later on the GitHub the tutorial on how to install the Postgres on your box. Okay, let's start with the motivation. So the motivation of this first module is to understand how important is the data modeling for a DBA and also for a data analyst. So, and to show you that without a good data model, it's really hard to control redundancy. The data, it increased dependence between the data itself. So, and it makes hard for the application to grow. It's make really hard if we want to build a better application. So with a good data modeling, we have more flexible standardization. So the data modeling is a lot flexible. It's easier to grow. It's easier to evolve. So, and when it gets easier, it will also increase the productivity. And we'll see that when we have good defined data model, it helps with defining the whole architecture of that, not only the application, but for the database as well. It has impact when you're designing high availability. It has impact when you're designing the application itself. It has impact when we need to improve performance, when we need to improve security. A good data model impacts a lot on the whole life of the database and of course on the whole job of the DBA. As I said, as a good data model is really critical for data consistency and accuracy. So if we had a bad data model and we don't have consistency, the data is mostly useless. So if you have a 1 terabyte of data that has no consistency, it's not accurate, it's just trash. You cannot extract information from that data. We cannot build decision on top of that data because it's not trustable. We cannot trust on the data. So it also helps with maintenance of both the data and of the data model. So if we have a good data model, it's easy to understand what the data fits. It's easy to understand how to build reports, how to build applications on top of that data model. And of course, it's easier to improve performance. Okay, but is data and information the same thing? I've been talking here about data and information, like, and sometimes we just interchange them, just if they were are the very same thing. Actually, data is not the same thing as information. Data is the foundation, is the raw material that we use to extract information of something. So the data itself has no meaning. For example, I have this chart here and this table here, and I also have this diagram here, this chart here. If we look at those, we see a lot of data here. So like, for example, I see the salt concentration and light transmittance, and I see that has some percentage of concentration, probably to measure the saturation of the salt. And I have some trials here and another numbers, like I have no idea what they mean, because, well, they're just data. They have no meaning for me. If I do not know the context, if I do not know how to process this data here, it's just a bunch of numbers. There's no context. The same as this chart here. So it looks like a nice sine wave here, and based, well, I would say it's just maybe something related to earthquake or weather, but like it has no meaning. And to produce this chart here, we have around 2 million points. So it's a lot of data. But data by itself is useless if we do not give any meaning to that data. If you do not have any means to process the data and to build information on top of that data, it's just useless. So, and what is information then? So information is the result of the data processing. When we get that data, we organize that data, we put some meanings on that data, and we use appropriate methodology, we can extract now information. So information has meaning. Information, it generates knowledge. For example, if I have a shop and I know that my shop is selling $100,000 on Monday, $150,000 on Tuesday, and then I can average that amount of data. So when I say that my shop sells $100,000 of goods on Monday, I'm giving meaning to my data now. It's not just a number anymore. So if I get all those, if I can average, I can process averaging that data, I can see, for example, a historical chart to see what are the days that I sell the most and they sell the less from the last year. And I can make some promotions, right? I can like try to get more customers on those days of the week that I don't sell much. Or I can see what are the products that I sell the most and maybe put some promotion on that products during the days that we don't sell much. So when we have information like this one, we have knowledge, we have support to make decision. And this is the main difference from data and information. So we need the data because we're gonna build information on top of the data. But the data needs to be organized, the data needs to get meaning associated to that one, and we need to have the proper methodology to build information on top of that data. Okay, now that we know what is data and what is information, we can jump in to see what is a database. Well, the database is just the grouping of similar type of data or data with a similar subject. So in summary, when we have a collection of data that is organized on the same topic, on the same subject, then we have a database. Like if we see here on this picture, we have a database here. Well, it's kind of old school, right? But it's still a database. When we talk about database, the first thing that usually comes to people's mind is something related to the software. Well, database not is was not only related was not related to software before. So it was really on old times. It was really old school, or as we can see here, it was analog. And one of the main things of the database, they are intended to facilitate people's life. So when we do an insertion, or when we need to consult, or we need to search of to change the data, if the data is organized in topics, and if the data is organized using a methodology, so it's a lot easier to find that data. Also, it's easier to secure the data. For example, here in this example, we can put this in a safe, or you can put in a very safer storage. So it's a lot easier to get this data secured. And the usability from the end user is improved. So because of all of those things, we have reduced maintenance time. We don't need to spend a lot of time searching for the data, or we don't need to spend a lot of time keeping the data organized, because we've been reduced the complexity on the database. And those are the main things. And of course, it's to reduce maintenance costs of the database. And as I said, the database, they can be analog, like that the binders and archive that we saw on those pictures. A photo album is also, we can be considered also as a database. Books, a library is a huge database, right? So they're all analog databases. And we have the digital ones, the ones that we are going to work, right? So the digital database, we can relate them like a spreadsheets or text files. Like if you have a CSV text file, it can be related and can be used as a database. It keeps data organized within topics and subjects. Database, they're most commonly used by application, usually not humans, and those are the digital ones. So from now on, every time that I talk about database, I'm going to talk about digital database, the software databases, right? So, and they usually not used by humans. Usually when you use a database, we have a software that is automating the use of the database. We usually do not have direct interaction to the database. Well, unless you are a DBA, right? So, and if you are here, I suppose you want to be a DBA. So you were not in this one, so probably you're gonna use database a lot more than the majority of the population. And you are just an exception now, right? Because most of the database, they just use it by application. Like when you go up to a website, when you order food for that nice application, so that nice application is connected to the database. You are not accessing the database directly. It's the application that usually accesses the database. We'll see that those imposes a lot of complications for the DBA, a lot of limitations as well, because during the time that we're working with the databases, we need to be careful to do not impact the applications while we're doing our job, we're doing some maintenance, or we're running something. And one thing that has been happening in the last years or last decades are that the amount of data that we're collecting and storing in our database, they've been increasing quite a lot. So 1 or 2 decades ago, when we used to talk about gigabytes, they were a lot. They usually tended to be a huge number. Now, database, we're talking about terabytes. And probably soon we're gonna scale up, right? So, and this increasing in amount of data is increasing the complexity. Can you imagine keeping 100 gigabytes of data inside of spreadsheets or CSV files? that would be insane, right? And because of this, all those complexities is how it started those database management systems. The database management systems, they're softwares that we use to manage our databases now. And in that category is where we get the Postgres. So what is Postgres is just a software that help us with maintaining huge databases inside of it. So there are a database management system, right? So and they facilitate the maintenance of those ever larger databases. They facilitate the user interaction with those databases. Now we don't need to go to a spreadsheet anymore and try to see, okay, which row, which column we have some information, or we don't need to write those VBAs or have those complex relations between one spreadsheet A and a spreadsheet B, or those tricking formulas. And so that always crashes those spreadsheets, and then we need to go to recovery and do maintenance those days. So we don't need to go back to that anymore. Can you imagine working with those large databases, terabytes of data, using that old school spreadsheet approach? That would be unmaintainable, unsustainable. And that's why we do need a modern database management system, right? And well, they also bring other things. They increase the data security. A main point of a database management system is also to increase data security. When we say data security, we're not only talking about data access. Data access to prevent somebody that doesn't have the privilege to access the data, yes, it's very important. But also to keep the data secure from a crash is also a lot important. Can you imagine that you have one database, you have a website that you are selling, we have an e-commerce. So your e-commerce is using the database here. And this box just crashed. Your e-commerce is not working anymore. You need to find a way to replicate this data to somewhere else, to make a copy of this database. In case of this box's machine, the server crashes, you have this data somewhere else. And then your application keeps working. So this we call high availability or increase in the availability. And those are some advantage that a database management system can give to us. So even if we have a crash here, your application is still available because you can have a copy somewhere else. And because like us, now that we have this availability, and we also need to think about data time access. So if you have this huge amount of data, it can be really slow to access those data. And the database should be smart enough to make the access to that data faster, even when we have like this humongous amount of data and increasing, so the data access should be faster. And faster data access, having high availability, and having all those, it can help us to make a better decision during the business time. So now we don't need to take so much time of that long as we used it to do before maintaining the database. We can spend more time making it smarter or making a smarter decision to the database. And the saving times, we can get them because we're using smarter database management systems, right? And there are many database management systems in the market. Well, for now, I'm gonna just call them databases. So there are many databases in the market, and some proprietary ones like Oracle and SQL Server from Microsoft. Well, Oracle is from Oracle, it's not from Microsoft, but SQL Server is from Microsoft. They are proprietary, they're closed source. It means if you want to use them, you need to buy a license. So, and we also have open source and free softwares like MySQL, Postgres, and MongoDB. So they are open source. It means that you can download the source code, we can change them, and depends on the license that they have, you don't need to pay any fee. For example, MySQL and Postgres, you can use them commercially, you don't need to pay anything because their license allows you to do so. One thing that is very important to understand is that open source does not necessarily means free. Open source just means that the source code that is built, that application, is provided when you get the software, when you get the license of that software. If it's that sold, that's not free software. So if who is selling to you is also providing the source code of the software. So we can have an open source software that's not free. But most of the open source softwares, they are free of usage, like MySQL and Postgres, and MongoDB, depending on how you use it. It depends on the license that you get. So among of them, Postgres has the most flexible license among of the list that we have here. So with the Postgres license, you can change the database, you can rename the database, you can distribute, you can sell, you can do whatever you want, because the license permits you to do so. So there are other types of license, they put some restrictions, and you don't have that much freedom. So when you use an open source software, be careful and always check the license to see that what you're doing with that software is allowed by the license that we are using. All right. Now, talking more about Postgres. As I said, Postgres is an open source software. And it's usually called in object relational database. If you're a developer, do not confuse the object here as an object, as in object-oriented language. It's not the same. The thing is, everything inside of Postgres is treated as an object. A table is an object, an index is an object, a view is another object, and you see, so, but in essence, it's a relational database. We'll see later, there are other types of database, just like MongoDB that we have here in this list, and Redis, they're not relational database, but it's not for today. We're gonna talk about this topic later. So I call not PostgreSQL, but I'm gonna start calling Postgres in short, because, well, it's easier and simple to say its name. And so Postgres is one of the most advanced database that we have in the market. And I would say it's even the most advanced open source database that we have in the market. So its project started in the University of California in Berkeley in the 1980s, like long ago. When it started, it was not relational database, and through its history, it's been changing a lot, and Postgre has a huge and strong community. So the community in Postgres is really, it's amazing. They always try to help people. We have events all over the world, all over the year. So during those dark times of the pandemics, most of the events, they've been done online. Now we're back into to have some on-site events. So if you can, please join the community. You can learn a lot from the community. You can find a lot of help from the community, and you can help the community, right? So the community is as stronger as the members are in the community. So, and this is one really amazing thing for Postgres is its community. So we can always find people that are willing to help each other. So Postgres supports most of the standard SQL, so and modern features, like we have complex constructions with subqueries, with window functions. We're gonna understand what those things later, and CTE. So Postgres supports really complex constructions using the database. Also supports complex objects like JSON. So we can, even though Postgres is a relational database, we can create tables with just a single JSON and put everything there, just like we're using a NoSQL database. I would not advise to do that. So you might find a lot of issues. Of course, there are some circumstances that JSON inside of Postgres are really useful. They can be really fast, and but they are not for everything. We really need to be careful when using non-relational features inside of a relational database, right? So it supports foreigners, foreign keys, support triggers, views, and a lot of many other things that we see all of them through the course here. Postgres uses a client-server model, and for now, it's just enough to understand that the server on the client-server model that Postgres uses is the guy responsible to store the data. So all the data, all the files, all the information, everything will be stored in the server. The client is the application that we're going to use to send the commands to the server. So when we write our SQL commands or queries, everything here, we will use the client. We're going to write in the client, and then the client is going to send that command to the server. The server will process, will do its magic, and then you send the result back, right? This is what we call client-server model. As this module is just an introduction, we're not going to go deep, but when we start to study Postgres, we will go a bit deeper and understand a little bit more about how that works. We'll see that there is a language, a protocol that the client needs to use to talk to the server. So we'll understand a little bit because sometimes we need to troubleshoot problems and then we need to understand that language. We need at least to know what they are talking to each other, right? Okay, now let's take a look on the Postgres itself, on the client. Sorry. Okay, here I have my terminal. So on this terminal, I already have installed Postgres. I'm using Linux here. You don't have to use Linux. You can install Postgres on Windows. You can install Postgres on macOS. You can install Postgres on a BSD. You can install Postgres on a Unix box. So you can install Postgres in almost everything. You probably can even install Postgres on your refrigerator if it has enough resource. So it's very flexible. The binary Postgres itself is really small. It's not large. A lot of embedded softwares use them. So I'm not going to show here how to install Postgres on Windows, or because I don't have a Windows box. But later on, this weekend I'm gonna put a tutorial on our GitHub. So I'll show GitHub and so on, showing how to install Postgres on Linux, on Windows. I'm gonna ask for a friend to do the step-by-step on his box, and on macOS. So the installation, the process is quite simple. You'll see later on. So I want to show you the client. This is the client. All the commands that you're gonna send, we're gonna use the terminal, the command line client, because we need to understand how to write queries, and the best way is using this guy. So if you feel more comfortable using a GUI application like a text editor or something, that's fine. So you can use later, that's no problem. So you can use the application that makes you feel more comfortable and be more productive. But at least for the moment, we're gonna use the terminal. So I can send comments to the terminal here, to the client. Like for example, the one that I just sent here is showing me the help. Those are comments that I can use in this client. I can remember that I said that this is a database manager. It's a manager that has built inside of it's managed different databases, more than one database. In my case here, I have those are tables. Sorry, I have 1, 2, 3, 4 databases inside here. This Postgres here. So this installation of Postgres is managing 4 databases. Now I'm connected to the database test. I can change from one database to another one using the \c and then the database name. For example, I can go for the database Postgres, and you tell me, okay, you are now connected to the database Postgres, and this is just the user I'm using. It has the same name as Postgres. We will learn how to create users later, but for now it's fine. And I want to connect back to the database test. Just go back to the database test. And for example, here I want to list how many tables I have. So I have 1, 2, 3, 4, 5, 6, 7 tables. I can ask the database, okay, what do you have inside of this table shop? Right? So when I ask into the database, I'm going to send a select. The star here means that I want all the columns from that table. If I do not, the table is just the front table shop. If I do not, the database, I want a restriction, it's going to show all the lines as well. No worries, you don't have to understand this for now because it's going to be the topic of the next classes. So I just want to show you the terminal where we are going to work. Yeah, this is the guide that we're going to use here. So no worries if you are not understanding, that's okay. I just run here. This here, it just brings me all the lines that they have inside of this table. You can imagine this just like an Excel spreadsheet, right? Just looks like an Excel spreadsheet. So we have, like in my case here, shop ID, shop name, and shop city. So the IDs go from 1 to 12. The names here, I have shop 1, 2, 3, 7 up to 12. And the cities, at least the cities are a bit different, right? I have Luxor, Cusco, Hanoi, Bible, Sydney. So this is my table shop here. We'll learn how to manipulate this data, how to insert the data, how to get the data. So for now, it's just to show you how it looks like here inside of my database, right? So another thing is we have the Postgres here, the website. This is just postgres.org. On the website here, you have the download page. As I said, you can download Postgres to install on Linux, macOS, Windows, BSD, even Solaris here. Well, it's still alive. Yeah, you can install on Solaris if you have one. And for the ones that you don't have here, it's open source. Remember, you can just download the source, compile for your architecture. It's not complex. We're not going to see this in this module, but when we start to talking about Postgres itself, we'll learn how to compile Postgres for at least for the main architectures that we have here. Linux, Mac OS, probably, I don't know Windows because I don't have a Windows box, and I don't want to buy a Windows license. But I'll try to find out to see if I get Windows here, or someone that has a Windows, and we record and we post there, right? Another thing that I would like to show you is our GitHub. So all the things we're posting on the GitHub. This is the GitHub of the training. So we have here tutorials DB. This one that we're learning now is data and SQL. I'll post everything there. So for now, I still don't have here, but I'm gonna update this Sunday for those ones that speaks Portuguese. So we already have some material there. Um, we are working to have the translation of the material from English to Portuguese to Spanish and Chinese. So if you go here, we already see some stuff in Chinese. So we're trying to get. And if you speak whatever other language, like even like Chinese or Italian or Japanese, or I don't know, that hundreds of maybe thousands of languages out there. If you work, if you do, and if you know English, if you want to help this project with the translation, we really appreciate and we welcome all the help. We are also creating some challenge from time to time. For example, last week we created the first challenge as a warm up for this training. So, and some nice people they've been sending their answer to the challenge. The challenge, this first one was to get those two tables here that we have, use only one select, one command, and create this report. So this challenge here explains how it's important to have a good data model, because if you can understand the data model, we can improve performance. For example, the first answer that I got for this challenge was solving the challenge in around 1900 milliseconds. It was 1.9 seconds. Then I got another answer that solves the same problem, that gets this very same result, running in less than 1 second. It was from 1900 to 900. See, it was 1,000 milliseconds faster. The last one that solved this problem here, it was running in less than 160 milliseconds. It was 10 times faster than the first query. And it was possible because, well, we do understand how this data model works, and we have a good understanding about the database, and we didn't change anything on the database. Anything. It was just how to write the query, how to write the select, that we got that huge improvement. And this is what we aim for this first training. So when we finish this first module here, we should be able to write this very same query here, and we should be able to at least start analyzing the differences. And for example, I just want to show you, this is one of the queries that was really nice written. And this is another one that was also really nice written. So they both solve the problems. They're both under the limits that we imposed for this challenge. So I recommend you going there, understanding them. So if you go for the pull request that we have here, so I usually try to give some hints or to see what are they doing. And for this challenge here, I started to writing the analysis of the challenge. So here we have the start of the analysis, that they explain how the query was written and everything there. So the first one, how to build. I don't expect everybody that are starting this training now to understand what is here, because, well, we still don't have all the knowledge to understand, but we will. This is the main goal. So when we finish, to write those by ourselves and understand how they work. And yep, that's what we have for today. I really appreciate everybody here that's here. So I see you next week. Before I go, I'm gonna post an exercise. So you need to solve that. Is just installed Postgres on your machine. So I'm gonna post the exercise on GitHub. Actually, all the exercise from this training we're gonna post on GitHub. And it's very important that you solve all the exercises. So remember, we are here for a formal training. Of course, we're not going to use all the formalism that you have in the university, but we want to make it a formal training. So we have a logic way steps to go through, and all the exercise that we post, they're important that you go and solve those exercises, right? And well, that's it for today. Thanks for everybody here and for you that are watching later the recording, and see you next week. Have a good weekend. Bye.